the organic TA, and today I will walk you through the extraction of the caffeine from the tea solution, sublimation of the caffeine after that we extract, and at the end we will check the melting point. I will start with the material for today's experiment. First one is tea solution. Our preparation team made this solution with using 2 tea bags per 10 to 12 milliliter of the ionized water. We need 10 milliliter of this tea solution. Saturated sodium chloride, dichloromethane or DCM for extracting, and then sodium sulfate as a drying agent. The last one is the sodium carbonate. Sodium carbonate will saturate our aqueous phase and force the caffeine to go to organic phase, which is DCM. I will use 10 milliliter of tea solution for our extraction. So take a clean centrifuge tube and pour 10 milliliter tea solution that the preparation group already prepared for us. I will cap it and put it aside. Then I will use the balance to weigh 2 grams of sodium carbonate. Just get a weight paper, open the balance, put the weight paper on the scale and tear the scale. Please record the volume and weight of each material that I use as you need it for writing your lab procedure for your lab report, plus answering my question during the video. And right now you can see that I almost add 2.006 gram of the sodium carbonate. Now I will add the weighted sodium carbonate to the aqueous tea solution in the centrifuge tube. As the sodium carbonate solubility in aqueous solution at room temperature is around 17%, the 2 grams of sodium carbonate in 10 milliliter of tea solution will be a saturated solution, and the sodium carbonate will not solve completely. I will just use the glass rod, and by using the glass rod, try to break the granules and solve the sodium carbonate as much as possible. I can even cap it and invert the tube couple times to make the sodium carbonate as soluble as possible. But I should know that it will not be completely clear solution because it is a saturated system. Now question, how much is the sodium carbonate solubility in aqueous solution at 20 degrees centigrade? You need to answer this question in your lab report as the TA question during the video. So I will keep shaking and breaking the granules to make the solution homogenized and put it aside for continuing. I will measure 2 milliliter of DCM to a graduated small tube and add it to the centrifuge tube which contained the tea solution which we saturated with sodium carbonate. Dichloromethane is an organic solvent, and because we saturated our tea solution with sodium carbonate, the caffeine from the tea solution will force to go to the organic phase and extract from the aqueous tea solution. After that I mix everything in the centrifuge tube. I will cap that one, and while that I am keeping my finger on the cap, I will invert the tube several times. Be sure that you hold the cap and occasionally open the cap to vent the tube. This step will repeat couple times. After you finish this step, then allow the tube sit until the aqueous layer separate separate from the organic layer. If these two layers don't separate within 2 minutes, then the sample can be centrifuged for 60 seconds on setting number 2 of the centrifuge. Because I want to separate them faster, I will level another test tube and I will put them in the centrifuge. In the centrifuge, always you should be sure that you balance the centrifuge. For example, when I put my sample in the number 1, in number 5, I should put another tube in the same amount of the volume of the solution that I have over there. And if the density be so much different, you can weight that instead of just look at the volume. I will close that one and put it for the 1 minute for the number 2 setting, and I just will start that one. So it will centrifuge that for the 60 seconds. After 60 seconds, we will see if we get it separated. If not, we will repeat it again. Now, second question. I need that you answer me that how much from tea solution, how much from the sodium carbonate, and how much from the DCM I mix together for starting the extraction. So I will come back in a couple minutes to show you if I have the separated solution. Okay, so we came back after 60 seconds of the centrifuge. I will open the door of the centrifuge and let's see that if it gets separated. Yes, it gets separated. So I will do 2 more times. So each time I should remove this separated part and collect it in another centrifuge tube. So if you watch with me here, I will try to get with a glass pipette all of the organic phase that I have over there with a plastic bowl. I have a clean tube here. I will collect my organic phase here. So as you see, I remove all the organic phase that was in the bottom. I will add another 2 milliliter of the DCM and repeat the process 2 more times, collect that, and I will come back in couple minutes when I collect all the DCM after 2 more times of the extraction. I repeat the extraction from the tea solution 3 times and collect 2 milliliter of the DCM each time. It is all DCM that I collected from each extraction, repeated 3 times. So right now I will put this tea solution aside and I will continue my extraction with this DCM. Right now the caffeine should exist in the DCM, and I will add 3 to 4 milliliter of the saturated sodium chloride solution to a test tube, and I will add it to this organic phase that I have. How much was that? 3 to 4 milliliter of the saturated sodium chloride in the DCM. So I will again invert it. I should pop it out and vent it each time to let it to vent. Let me change the cap. I feel that this cap has like, and if you look at that, you will see the saturated sodium chloride will remove whatever that was remaining from the aqueous solution, and the organic phase, the DCM phase that I have, will get more clear. I will repeat this part 2 to 3 times, remove the organic phase each time, and I will come back after that I get clear the organic phase. Okay, I come back after 3 times adding the saturated sodium chloride, and this is the last one. The bottom part is the organic phase, the top part is the sodium chloride that we use for cleaning the organic phase and remove whatever that was impurities. So the things that I will do is that I will remove the organic phase from the bottom and I will add it to the new tube. So I will get everything that is in the bottom part and you will see the line. It is really easy to detect that where is the point that we should remove the solution up to. Okay, I almost removed all of my organic phase, and the sodium chloride, that is the aqueous waste, is the extra waste that I have, and I will continue my extraction with the organic phase. So if you follow me from the beginning of the video, we start with aqueous T solution, then we extract the caffeine to the dichloromethane organic solvent and add some saturated sodium chloride solution to that. Even during this step, I try to remove the layers very careful, but still my organic phase will be a little wet. For solving this problem, I will pour the organic layer into a new clean dry flask and wash the test tube with the DCM to remove all the caffeine from the tube, because the caffeine can stick to the wall of the tube. So I will just add a little of the DCM, shake it completely and pour it to the same clean dry flask that I collect my organic phase. I will repeat one more time to be sure that I get all of my caffeine from the centrifuge tube and don't lose any caffeine in this step. Now I will start the next step, which is drying the organic phase. In this step, we add 1 or 2 spatula tip full of sodium sulfate, which is our drying agent. But do not add too much of drying agent, because the drying agent will remove trace amount of the water from the organic solution. But if you add too much drying agent, depending on how much water remain in the solution, the solvent can boil. This is particularly a problem for low boiling solvents such as dichloromethane. Let the organic extract to sit over the drying agent for at least 5 minutes. Now, the third question that you should answer in your lab report is what happens if you add too much drying agent in this step? Now, in the minimum time, we will weight a dry, clean filter flask and record the weight. We need flask weight later, so please don't forget to record it. As I see, it is 31.036 gram. Please record this number as we need it for our calculation later. Now, they cut the dichloromethane extraction and put it in the pre-weighted filter flask that we have. Be really careful to don't lose any of the solution in this part, and rinse the sodium sulfate drying agent with a small amount of dichloromethane as well, and decant the DCM wash only in the weighted filter flask again. So we try to don't lose any of the caffeine in this step as well. And we will go to dry it out with the airflow and reweight it again. After that, we remove all the DCM. I just use the airflow to dry the organic DCM. The solvent can be evaporated by gentle heating on the hot plate as well, but I just use the airflow. When the DCM evaporates, the caffeine will be left inside of the filter flask. If the caffeine contains some impurities, we will see it is yellow-green residue. But as my caffeine is more pure, it is white color. After removing all the DCM, then weight the flask again, record the weight again, and use it to calculate the amount of crude caffeine. We will purify our crude caffeine by sublimation. We use sublimation before in experiment number 4. But if you don't remember this purification technique, please review experiment number 4 materials. But here you can see the sublimation setup which you used before and I will use today again. And now the first question that you should answer in your lab report is that why we sublime the caffeine after extraction. I removed a small amount of crude caffeine for performing the melting point of crude caffeine and use all the components for the sublimation. I set up my sublimation in sand bath and I wrapped the flask with aluminum foil and made sure that the pipette bulb is on the side arm of the flask. From the window that I opened, you can see that my sublimation is almost done, and the sublimation temperature of the caffeine is around 180. I just follow all the protocol and precautions for setting up the sublimation experiment, then collect the pure caffeine after extraction, weigh it, and you should record the weight and use that for your sublimation percentage yield calculation. I packed the crude caffeine and sublime caffeine in the capillary tube. I will perform melting point for both crude and pure caffeine. The left tube is the crude caffeine and the right one is the sublime one. The crude caffeine start melting at 234 and finish at 237 degree, and sublime caffeine start at 236 and finish 238 centigrade. So, in today's lab experiment, I walk you through the extraction of the caffeine from the tea solution. In your lab report, you should write the procedure and mention exact amount of each chemicals that I used today. Don't forget to answer the 4 questions that I asked during the video and calculate the amount of caffeine that I extract from the 10 milliliter of the tea solution, calculate the percentage yield of sublimation, and write the observation and conclusion based on our today experiment. If you have any question, ask during the mandatory Zoom meeting that you will have with your TA. Finally, make sure you upload your lab report before the next class. Stay healthy and have a good day.